let's talk about page 11, number 20, Roman numeral 20. Adding and subtracting rational expressions. Well, just like with regular numbers, when you add or subtract fractions, you've got to have a common denominator. It's just the way that it works. And when you do have a common denominator, that's one I was going to start with. For example wise, before I get to the book examples. All right, for example, so then it mentions once fractions have common denominators, then what do you do to simplify them? Well, let's just say we start with the common denominator. Both of them have denominator x. And so how does adding fractions work? Well, when you've got a common denominator, you add the numerators, and what happens to the denominator? Yeah, it just stays the same. So that's how fractions will be added together. Now, same thing for subtraction. Let me do one of those here. Do it down here. 4x over x plus 3 minus 2x minus 6 over x plus 3. Because there's a couple of points on this one. So I do have a common denominator, x plus 3, and so that's going to be what the denominator is when I add these together. Now, so I've got 4x, but let's do this because there's another slight little catch here. When I subtract, and I've got a binomial on the top, that's going to have to affect both of those, or that does affect both of those. Meaning, I've got that negative, that's like a -1 out there, and so that gets multiplied by both of those on the top. So when I subtract these, it's not minus 2x minus 6, it is minus 2x, but what about the 6? Minus times a minus gives us plus 6. See that? So that's the first thing. When you subtract like that and you got these binomials, if it was just 2x, that's obvious, but that does distribute there. You've got to distribute that -1. Now, when we combine those, so you got 4x minus 2x, combine like terms. Here's the next thing. We get 2x plus 6. 2x plus 6 over x plus 3. Now, the reason we're not done here is because notice the top, we can factor that. And sometimes factoring doesn't do you any good, so you don't have to do it. But here, if we factor the top, what can we do to factor the top? Factor out a 2, pull out a 2, and that'll leave me parentheses x plus 3. You see that? Yeah, there's a couple of them on the assignment where you get the answer and then that can be reduced. Like this. So factor the top, what can happen? Cancel those x plus 3's out. So the answer is just 2. So that's, doesn't always happen, but there are a couple, like I said on the assignment, where that is going to happen. So I wanted to mention those to you before we get to the examples. All right, so yeah, so that was the C part of that ABC on Roman numeral 20 there. All right, so let's get to those examples. Example 1 is 5x over, 5 over x plus 1 over x squared. Yeah, so this is not a common denominator here. And so we've got to make it be a common denominator. And in a case like this, let me just, usually we call it the least common denominator. Let's kind of identify that just so we're on the same page here. I've got x and I've got x squared as my denominators. Well, what can I make both of those be that would be in common? Well, in this case, X I can turn into x squared very easily. And of course, x squared is already x squared. So my least common denominator is going to be x squared, meaning that's what I'm going to make both my denominators become, x squared. That's my least common denominator, because you got to have that in mind before you proceed on. So the next step then is to figure out, well, what do I need to do to make that be x squared? Well, I got to multiply it by x. And we've done this a couple of times. We'll multiply that denominator by x. You got to multiply the numerator also by x. Multiply by the same thing, top and bottom. Now the good news is that one already has x squared, so I don't have to do anything to it. Sometimes you have to do something to both of them, but maybe just sometimes just do it to one. So what does this make us here? Let's go ahead and rewrite that. So that's 5x on the top, and then x squared on the bottom. Hey, look at that. Now I have common denominator, just like I did previously. So what happens? You add the numerators, 5x plus 1. Can't combine them because they're not like terms. And then the x squared denominator just stays x squared. That's done. All right? Now, the second one there. Second example below that one. So 3 over x plus 2 plus 2 over x plus 1. Well, the thing about that is, all right, so just like before, canceling, you got to have x plus 2, x plus 1, that's just two totally different factors. And so LCD-wise, that is, you just need a copy of each of those. For the LCD, it's just x plus 2 times x plus 1. And so I've got to make both denominators be x plus 2 times x plus 1, or you can flip-flop them there. So what do I got to do? Well, the first one, to make it be LCD, to have that LCD, it's got x plus 2, so I need to multiply by the x plus 1, top and bottom. Over x plus 1. It's got the x plus 1. So I need to multiply it by the x plus 2 to get it to be the common denominator. Let me move this over. All right. So what does all this mean? Well, what this means is now, notice, this denominator is x plus 2, x plus 1, and this one's the same thing. It's, in reverse order. So I've got that common denominator. So it just becomes here. But I need to add the numerators. Combine the numerators. Well, here's the thing. Let me go ahead and put parentheses there to kind of help us. What happens to the numerator here? Well, I've got to multiply those out. It's 3 times x plus 1, which you can write that way, but let's just kind of combine some steps here. That becomes, this numerator becomes what? 3x plus 3? Distribute that 3 there. Same thing over there on the right. The 2 times x plus 2, well, you got to multiply that 2 times the x plus 2, so that's plus 2x plus 1. So now we're in business, because now all we have to do is combine the like terms. So you got 3x and 2x, so that's 5x, 3 and 4 is 7. Ta-da. Final answer. Nothing cancels, nothing factors. That's it. Question? Not too bad. All right. Third example there. 2 over x squared plus 3x plus 2 plus 5 over x squared minus 4. So this one is an extra step here. Because looking at those denominators there, hopefully you're thinking, those can factor. Now, previously, we didn't have any that would factor on those last two examples. However, the word of the phrase of the day, factor first, applies here too. If you got something that factors, factor that first. So we've got denominator here that factors. Factor first. So factor this x squared plus 3x plus 2 is x plus 2, x plus 1. And we've got a difference of squares. So it's x minus 2, x plus 2. All right. So now, that's what I was saying. Let's identify our LCD because we can't add those because they have to have the same denominator. So we have to make it like we did both those previous ones where it has the same denominator. Now, notice here, how many different binomial factors do I have? I've got x plus 2, I've got an x plus 1, and that one also has an x plus 2, but it's also got an x minus 2. And so the LCD is going to be one of each of those. X plus 2, x plus 1, and x minus 2. Okay? And so I need to change that denominator into that, and that denominator into that. Well, how do I do that? Well, for this first one, what would I need to multiply by? It's got the x plus 2 and the x plus 1. And so I would need to multiply by the x minus 2. So top and bottom, multiply by x minus 2. On the second one, 5 over x minus 2, x plus 2. It's got the x minus 2 and the x plus 2. So I need to put in the x plus 1. So top and bottom, multiply by x plus 1. So let me put parentheses around these so you can see it. Yeah. So now this denominator is this denominator is that. Those are the same denominators, and so I can add them together. So it becomes x plus 2 times x plus 1 times x minus 2. Or you can write those in whatever order, but just need that denominator once here. What happens on the tops? Well, on the top here, I've got 2 times x minus 2. That's distribute 2x minus 4. Yeah. This top is 5 times x plus 1, so distribute there, you got 5x plus 5. And so all told, what do we have? 7x plus 1, and then x plus 2 times x plus 1 times x minus 2. So it's kind of long, but same idea. All right, let me do one with subtraction. And then I'll have one more after that. All right, so let's say we've got 6 over x squared minus 9 minus 3 over x squared minus 3x. Same as this one, those denominators factor, so that's first, factor first. So we be 6 over, that's a difference of squares, x squared minus 9. So that factors as x minus 3, x plus 3. Minus then 3 over, that factor out an x. Take out the x minus 3. Let me take out the x and leaves you x minus 3. All right, so what's the LCD there? What is the common denominator that I can get on those? Well, the one on the left has x minus 3, x plus 3, so I need those. But this one has x and x minus 3, so I also need an extra x there. Yes? I need 3 factors. I need x minus 3, x plus 3, and then I also need x. I already have the x minus 3. Okay? So what do I multiply the first one by? X, yeah. So 6 over x minus 3, x plus 3, it doesn't have the x, so multiply x over x there. And then the minus 3 over x, x minus 3, well, it doesn't have the x plus 3, so multiply by it. And again, I'm going to go ahead and throw some parentheses around those. Here's why I wanted to mention this, all right? So, yeah, so now we have this common denominator. So we can, same thing for subtract as add, you need a common denominator. And when you have a common denominator, when you subtract them, you just bring that common denominator once, just have it all together, if you will. So the denominator of all this is just going to be x, x minus 3, x plus 3, or whatever order you want to write those in. On the tops, what do I have there? Well, I have this 6x. So that's easy. But this is why I want to mention this, okay? So what do I have over there on the right? Well, yeah, I have the 3 times x minus 3, but what about this? Isn't that negative 3 times x times 3? Yeah, you've got to factor that in too. So it's minus 3x minus 9. With me? So we've got 6x minus 3x minus 9. Now we combine, of course, like terms. You got 3x and then the minus 9. Which usually that's where we stop, but you notice something here? The top factors. Common factor of 3. So if I factor that common factor off, look at that. You can cancel those x minus 3 out. So there's a couple of them that happens. And so be watchful for that. So the final answer is 3 over x times x plus 3. Yes, sir?
So since we're working with factoring all together, you wouldn't have been okay with 3 parentheses x minus x plus 3 ending parentheses?
Say it again.
Go up 3.
Right here?
Yes. You wouldn't have been okay with negative 3 parentheses x plus 3?
Yeah, you need to multiply those.
You want to...
Yeah, multiply those in. Multiply those together, yes.
All right.
Because, for one thing, it simplifies at least to that, and then it simplifies on down.
Right.
So
I figured it's
yeah.
through factoring. I mean...
Oh, yeah.
It
Yeah,
makes sense.
so factoring sometimes helps, sometimes doesn't. And yeah, we wouldn't want to leave that one like that.
All right.
All right, got one more to show you. Then we'll be done. This is a complex fraction. There's a couple of these at the very end of the assignment. So let me show you one little quick trick on these. Complex fraction. All that means is you've got a fraction on top of a fraction. So you've got a fraction made up of fractions. Complex. For example, 3 over x plus 1 over 6. So you're adding 2 fractions. Divide that by another 2 fractions, 2/3 minus 1 over x. Okay? That's what we mean by complex fraction. That's pretty complex of a fraction, isn't it? Because you got fractions on the top, then you got, well, you got a fraction, and then you got fractions on top of the other fraction. So that's what we mean by complex fraction. Now, to simplify this, one quick way to do these, the ones we've got in the assignment here, is to do this. So we've got denominators on the top and on the bottom. So let's just think the LCD for the whole thing. So I've got x, I've got 6, I've got 3, I've got x. So if I was going to come up with a least common denominator for all of those, well, of course, I need an x. And then I've got 3 and 6, so I would need 6 for that. I mean, you could do 18, but 6 is fine. You with me there? Here's the little trick. Let's multiply by that top and bottom. Multiply by 6x over 6x, that least common denominator. Now, what that means is, since the top here is multiplied by 6x, let's write it up here a little closer. What do you got to do? You got to multiply that and that by 6x. So let's do that. So you got 3 over x times 6x. And then you got 1 over 6 times 6x. And then the same thing on the bottom, you got to multiply both of those by 6x. So you got 2/3 times 6x. And then you got minus 1 over x times 6x. Here's why this works out so very nicely. You see, what happens is a lot of canceling. Like here, that's 6, now it's 6x over 1. Yeah, you can cancel those x's out. And so you just have, for that one, you just have 6 times 3, 18. These 6's cancel out there, and so you just have plus x. Oh, down here, the 3 goes into the 6 and leaves me 2 there. So you got 2 times 2x, so that's 4x. And then you've got the x's canceling once again, so that's just minus 6. So you can use that LCD on that one to our advantage. Any questions on that one?